well. It is the last class, geometry class before spring break. There is school tomorrow, so don't skip out on school tomorrow. But we have some things we need to do, and unfortunately, we will have a homework assignment after this. So I would recommend getting it done ASAP. Okay? So let's go ahead here and take a look at what we got with this warm-up, and then we'll go from here because we got important stuff to do today. All right? And as always, if you guys have questions, please make sure to use chat to ask questions, or you can turn on your mic. Remember, with chat, you can send me a private message or you can send a global message. Okay? So let's go ahead and take a look at this. If you're following along in the book today, we are going to be following section 5.7, which is on CPCTC, which is more than just fun to say. Okay? So let's take a look at what we got here. So what are the 4 ways to prove triangles congruent? Right? So we got SSS, we have SAS, we have ASA, and AAS. Now, I always write them in the same order, but there is no order in how to write them. You just need to know that there are 4 ways to prove triangles congruent, and I can't emphasize this enough. That is so important, okay? Because what we're going to be doing today is what comes after proving triangles congruent, right? So it's what happens after proving triangles congruent. So a couple other things that I want you guys to be aware of, especially the people coming in late. There is going to be a homework that's going to be due next class. So my advice is don't wait until Sunday night of spring break to get it done. Just get it done right away. So make plans to do that soon. And then make sure you guys are turning in all your missing work. I have a lot of people who are not turning in work at all. So this is the reminder that 80% of your grade, right? 80% of your grade, right, are these assignments, are assignments. Okay, so make sure you guys are getting these done. Turn in your work. I have so many people who are not turning in work that people's grades are not looking great. Okay, also remember there's no late penalty. Oops, I should say no late penalty. Penalty. Oh my gosh, whatever. Okay, so there's no late penalty. Make sure you guys get that in. Okay? All right. Again, if you guys have questions today, always make sure to use chat and or your mic. Okay? So let's go ahead and get started in this. So again, we're doing 5.7 today. And 5.7 is about CPCTC. And that's what happens, so it's what happens after proving triangles congruent. After proving triangles congruent. Okay? So CPCTC, it's what happens after proving triangles congruent. So we're going to start out here. We're going to be taking a little bit of notes, and then we're going to be practicing using it like crazy. Okay? So the first thing is, what the heck does CPCTC even mean? Okay, so to do this, I'm going to write out a formal definition, but then I'm going to also go ahead and write out a non-formal definition, so that way you guys can pick which definition you want. Okay, so the formal definition says corresponding, okay, so that's the first C, corresponding, and then the P is parts. Okay. And then of congruent. Okay, so that's our third C. So we have corresponding parts of congruent. I'm running out of room here, so I'm going to go down below. Congruent triangles are congruent. Okay, so that's literally what CPCTC stands for. Okay, so corresponding parts of congruent triangles are congruent. Okay, so that's CPCTC. Okay, now we're going to have to do a little explanation of what that means, how do we use it, etc. And I kind of gave you guys a hint up here at the top. It's what happens after proving triangles are congruent. Okay. Okay. So now the reason for this is we only need, right? We only need 3 parts to prove triangles congruent. Okay, we only need 3 parts to prove triangles congruent. And when I say 3 parts, right, that's why we had this warm-up, right? We only need 3 parts, corresponding parts, to prove triangles congruent. So we only need 3, right? So that leaves 3 parts left over. Okay, that leaves 3 parts left over. Okay. So what we're going to be focusing on today is CPC is about these 3 parts. CPCTC is about the other 3 parts. Okay, and this is really like you use CPCTC in real life all the time. You just never knew it. Okay, so for example, if I'm checking out TVs, let's say I go to the store and I'm like, oh man, check out these TVs, and then you see one TV and it's like $800, and you see this other TV and it's like $600, and you're like, why is this one so much cheaper, right? So you compare them. Right now, you don't probably compare everything, right? You just compare a few things to say, hey, what's different, right? And that's kind of what we're doing with triangles. We only need to compare a few things in the triangles to know that they're the same TV, right? But there's a lot else going on with the TV, right? Okay, so this is the CPCT is about those other parts, okay? So like you might be like, okay, I know that these TVs are different. So then you go into greater detail. Okay, so like, is it worth it for that extra money to get all those extra features? Do I need those features? Okay. So let me give you kind of my definition. So here's my definition of this. Okay, so my definition of this is if 2 triangles are already congruent. So if 2 triangles are already congruent. So if 2 triangles are already congruent, then all their corresponding parts so if 2 triangles are already congruent, then all their corresponding parts must be congruent. Okay. So basically what I'm saying is if 2 TVs are the same TV, do you need to really check that every single part's the same? Or, right, like if, let's say it's the TV I'm looking at is a Samsung, and it's a Samsung X28. I don't know what the model numbers are. But if you see another TV and it's called a Samsung X28, then you already know all of the corresponding parts are congruent, right? If it's the same TV, then you know all the corresponding parts are the same. So that's the same thing here. If we know 2 triangles are congruent, then all of the corresponding parts, right? So if we just use 3 to prove triangles congruent, all 6 are going to be congruent. That's what CPCTC is. Okay. And does anybody have questions about that? So CPCTC is you've already proven the triangles are congruent, but that just means all of the parts are congruent. So you don't need to prove all 6 parts because CPCTC will apply. Okay. Thank you for the feedback. I appreciate that. I appreciate the direct messages. I think it's a cool way to interact. Okay. Right? Because it's private. All right. So, again, the most important part here is this, right? The condition. If 2 triangles are already congruent. So this has to happen after you prove triangles congruent. So you know how we did all those proofs and semi-proofs where we're like, hey, these triangles are congruent by blank. This would come after this. Okay, so it's just adding one more step to our proofs. Okay, that's it. That's all there is to it. We're just adding one more step. Okay. All right. So we're gonna do some problems with this, and then yeah, we'll call it good. All right, so let's do a bunch of examples together. So let's do, here's our first example together. We're gonna do like a quasi proof. Okay. So let's say let's start with something that we've done before. Okay, and then, so kind of a Star Trek symbol like. So let's say it's A, B, C, and D. Okay, and then I'm going to go ahead and add some givens. So again, we've done this problem before, but I'm adding something to it now. So what I'm going to say here, I'm not going to say, are these triangles congruent? I'm going to say, are angles, oops, I should just say, are angle A, grammar every time, is angle A congruent to angle C? Okay, so when you get a question like this, the golden rule that you need to remember, guys, is all we're doing in this class is that we are proving triangles congruent. So if I was writing steps, we are always prove triangles congruent first. Okay, oops. I just want to make sure you can see that. So step one, always prove triangles congruent first. Without any doubt, that's the first thing we always will do, okay? And for right now, any proof we do will always be about proving triangles congruent, okay? And I just want to reemphasize that. Any proof we do is proving triangles congruent. But you're going to be like, but Mr. Kraft, it doesn't ask us to say, hey, are the triangles congruent? You're right. But guess what? If these triangles are congruent, then doesn't this have to be true? Okay? And what I'm trying to say is here, if this TV is the same as this TV, then shouldn't these two parts of the TVs be the exact same part? Because if they aren't, then they aren't the same TV. Okay? Is that analogy working with you guys? Does that make sense, right? So we're always proving triangles congruent, because if this triangle and this triangle are the same, then all of their corresponding parts have to be the same. Okay? So we're just taking what we're already been doing, and we're just tacking on one step at the end. Okay? So first step, we're going to prove triangles congruent. Okay? So remember, I have S, 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 A, S, A, S, A, and A, A, S. So what do you guys think? Are these triangles congruent? Do I have to add anything? So in chat, you guys gotta, right? We participate in this class. So what have we got? Do we got, are the triangles are congruent? Yeah, we need one. We need more information. So where are we gonna get that more information? Ooh, you have the right idea, but I think you wrote down the wrong letters. Okay, nice. So I'm getting, oh guys, oh my gosh, it's just pouring in. You guys are on top of it. Some people are already just jumping right to like, it's gonna be this, which is good because we did this last class, right? So we should be there. So a lot of people are pointing out, I only have two pairs of angles, right? So I have an A and an A and an A and an A, and then I need one more pair. So I'm gonna say, right, I have a pair of sides right here. So I might start saying that, hey, segment BD is congruent to segment BD, right? That's the reflexive property. Okay, prop. I'm going to abbreviate prop there. So reflexive property, right? So I'm going to add that in. Okay, so again, I hope you guys are getting comfortable with reflexive property, right? So they share a side. And then we take a look. I have ASA and I have ASA, right? The side is in between. So see how this side is touching two angles? So then I'm going to pick the one where the S is touching two angles, right? So you see how the side is touching both angles, and in here the S is touching both angles. So I can go ahead and say triangle ABD is congruent to triangle CBD, and I can say that by ASA. So the first thing I did is prove the triangle is congruent. So the first thing, we do what we've always been doing. So be careful. Reflective and reflexive, actually, I know it's annoying, turn out to be two different things, because a reflection is actually a transformation, and a reflexive property is something equal to itself. And isn't that annoying, right? But it's just the way life is. But don't worry, if you say reflective when you're trying to say reflexive, I got your back. I know that's what you're trying to say. We just made a mistake, okay? So I'm not going to grade down for things like that, okay? And I wouldn't do that if we were in person either. I would correct you, but I wouldn't mark you down. All right. So first thing, always prove triangle is congruent. And then second, then use CPCTC to show other parts are congruent. Okay? Then, right? So this comes second. Okay? This comes second. Then use CPC to show other parts are congruent. Okay? So we just said these triangles are congruent. Okay? So is angle A congruent to angle C? Absolutely. Because if the triangles are congruent, then every corresponding part is congruent. Now, remember there's three parts, right? You guys remember there's three parts? So I can use CPCTC in a triangle. I can use it 3 times, right? So that's my proof, right? That's my proof. I just want to, but I could also say, right? Like, couldn't I say segment AD is congruent to segment CD by CPCTC as well? Right? And couldn't I say segment AB is congruent to segment CB by CPCT as well? Right? So I only needed one of them here, but just remember these other sides that are corresponding, those should be as congruent as well. Okay? So obviously you don't want to do more work than you need to. So if it doesn't ask for these two things, then you don't write those two things down. I just want you guys to know, right? If there's 6 parts to a triangle and we only need 3, then there's going to be 3 that we can use CPCTC with. Does anybody have any questions about this? Okay. Well, I'm going to have you guys try one of these on your own. Okay, sound fair? We're just going to try one on our own. Okay. And I'm going to use shapes that you're familiar with, because what's new isn't the proof, but it's good practice to do the proofs. Okay, it's good practice to do the proofs. So we're going to have this be a try on your own. Okay, so let's do this. This is a try on your own. Oh, man. Yeah, I'm glad you're back. I'm glad you're back. I'm going to make a problem. Okay, so let's say I'm going to go like this. I'm going to do a bow tie problem. So I'm going to have B, A, T. E, D. So that way we can get Ted Bat or Bat Ted, or I don't know. Okay, so we have this. And I'm gonna make it interesting so that you guys have to think a little bit. So we're gonna have some givens. So T is the midpoint of segment AD. and BE. Okay. And we're going to prove that segment AB is congruent to segment ED. Okay, and I want you guys to try this one on your own. And so I'm going to give you guys, 3 minutes. Okay. So, and you guys don't have to do, I just want to be clear on this. You don't have to do a 2-column on this one. So if you want, you can just write down every step, but write down every step, okay? So T is the midpoint of both AD and BE, and we're going to prove that these segments are congruent. So let's see what happens. We've done this proof before. So remember, you're first proving the triangles are congruent, and then at the end it's CPCTC. All right, let's take a look at what we got, guys. And remember, you can always ask questions. So if I did something that's confusing or if you're confused, remember, we're going to be making progress. That's what's really important, okay? So, oops, I'm frozen. Call me Elsa. All right, so taking a look at this. So I have givens. So I'm always going to address my givens. So remember, if T is a midpoint, that means I'm going to have two things that are congruent. So if T is a midpoint here, then that means that these two are going to be congruent. So I'm going to write segment AT is congruent to segment DT, right? And that is definition of a midpoint. Right, so I'm doing like an informal proof here. I'm not writing down everything so that we can save time, right? Okay, so I have these two by definition of a midpoint. Okay,
And then it says T is also the midpoint of BE, which would mean this is congruent to this, right? And that is also definition of a midpoint, right? If it's in the middle, then those two have to be the same, right? That's a definition. Okay, so this is definition of midpoint.
Okay, I'm going to pause there for a second. Does anybody have questions about that? Notice how I use different tick marks for each, right? Because, and I wish I had multiple rulers. If I had multiple rulers, I'd show you this. It's like a foot-long ruler and a meter stick, right? They can bisect each other, but that doesn't mean all their lengths are the same. Okay.
So again, I use definition of a midpoint to get this. And remember, our goal here is we want to prove triangles are congruent.
All right, so I should write these down.
So we got two pairs of sides, right? So I got two pairs of sides.
So it looks like I either need another side, but that's what I'm trying to prove. So I'm not going to be doing that, right? So I need to find a pair of angles. So can you guys help me out in chat? What do we got for a pair of angles? What angle rule can I use? So if you can't name the angles, what angle rule should I be using here? Right? And this is one that we've seen a couple of times, right? So what angle rule am I using here? Oh, dang. You guys are using, yeah. Ooh, it's not gonna be ASA.
You're really close though, because
what I'm gonna have here is people are saying vertical angles. So that's gonna be these two angles right here in the middle. Okay? And I know sometimes it's difficult to do these, but all it takes is just naming one. So for example, if I name this, I might go BTA.
So angle BTA.
And just get that first angle down. So I just traced it. I went BTA because then I can take a look. Okay, what does B go with? B has to go with D.
Right? So then I'm going to have is congruent. So I'm going to have angle D. And then what's T go with? Well, T is going to go with T. And A is going to go with E. And then I'm going to say vertical angles.
Okay, and if you guys are still struggling with the properties, that's okay. But remember, all of these we took notes on the first day of the trimester. That YouTube video is up. And it's just a refresh of everything we did first trimester with geometry, whether that was first trimester or second trimester, right? Geometry A, we did these things. So if you guys need more help with that, then A, check out that video, and B, come to my office hours. I can help you guys out, okay? Like I'll help you guys out with questions, with homework, anything you need. You just can come to my office hours. All right, well, let's take a look at what we have. We have a pair of sides here and a pair of sides here and angle here. So it looks like I have an angle in the middle and the angle is touching both sides. Do you guys see how I have an angle in the middle and the angle is touching both sides? So that would be this one, an angle in the middle touching both sides. So I can go ahead here and say triangle. Notice how I switched from an angle to a triangle, and I can just reuse the letters because I already put a lot of hard work into that. Triangle DTE, right? And then I can say by SAS. So I'm using a healthy amount of SAS going on here. Now I'm going to hit pause for a second. I want to make sure you guys, if you have questions, you guys can ask questions. Does anybody have questions so far? Or like, Kraft, what are you doing? Who are you? Who do you work for? I work for Mount Vernon School District. Anybody have questions or comments or concerns? Okay, so we proved the triangle is congruent, right? So then the question is, if these triangles are congruent, are these two pieces... Oh, I got a question. Yeah, you know what? I think you're right on that one. So I think maybe I should have switched these. Yeah, I should have switched these. So, hey guys, don't worry too much about this right now. Sorry. But someone did point out that technically I was incorrect. So I'm gonna switch this. They should go with D. And don't worry. Hey guys, if you're not super invested in this, don't worry about this, but technically, yes, you are correct. Sorry, I'm so focused on CPCTC that I kind of just made up this problem from scratch and I didn't put a lot of thought into it. So thank you. Thank you. You're absolutely correct. And then what about this? AD. Oh yeah, that doesn't worry.
Okay. All right. So the last piece then is,
If these triangles are congruent,
are these two segments congruent? Absolutely. Right? That's the takeaway. Right? They're congruent, absolutely. And why? Because corresponding parts of congruent triangles
are also congruent, right? So corresponding parts of congruent triangles are congruent, right? So that's what CPCTC means, right? The triangles are already congruent, so then all the other pieces
are going to be congruent as well.
Okay, what do you guys think? Should we do one more of these? Let's do one more.
Let's do one more.
Yeah, let's do one more.
I just want you guys to know that I'm
running out of
proofs to do.
So let's do one with parallel lines. So let's do ATE and CD. All right, and it's given that segment AT is parallel to segment CD, and that segment TE is congruent to segment DE, and you're going to prove that segment AT is congruent to segment CD. Okay, and I'm going to give you guys 3 minutes to work on this. So remember, the first thing you're going to do is you're going to prove triangles congruent. So let's give it a shot, and then we'll go from there. And this will be the last of these that we're going to do because I want to show you a cool example of how these can be used to measure things that we can't measure directly. All right, so let's go over this, and then I'm going to show you like a cool use of this in the quote real world. All right. All right, so let's take a look at this. So again, I have my givens. So the first thing I'm going to do, if this was a formal proof, right, we would write out all our givens. But I'm just going to go ahead and it says, okay, AT is parallel to CD. Now remember, parallel doesn't mean congruent. So that just means that they never cross, right? So those are parallel. And then it says segment TE is congruent to segment DE. Okay, so if you remember, I think we did a problem just like this last class. So this is going to have more than one way to prove it congruent. Okay, so we need, right? So we have 4 ways of proving triangles congruent. Okay, we're not going to be able to get any sides in this, right? There's no midpoint, there's no bisector, we don't have isosceles triangles. Okay, we're not going to be able to get any sides. So can you guys help me in chat? How am I going to get more angles here? How am I going to get more angles? All right, perfect. So right off the bat, like just like the last one, we have vertical angles, right? So I can go and add those in, right? So again, to name these, I'm just going to start with one. I'm just going to go angle AET. So angle AET. I'm going to be better this time about going with what, right? So A doesn't have anything marked on it. So then that's going to go with C. And then the E is in the middle. And that leaves us with D. Okay. And then I'm going to say vertical angles. Okay, so I have a pair of sides and a pair of angles. Well, again, I can't get another pair of another pair of sides, so I need another pair of angles. So I already see 1 or 2 people are already on top of it, but we haven't used our parallel lines yet. So what did we do last time, guys? What did we do with parallel lines? There's 4 angle rules, right? So which one can we use here? Right? Is it corresponding? Is it alternate interior? Is it alternate exterior? Or is it consecutive interior? So again, we should have this in our notes, and that's the beauty of this, right? All of our tests and homework are open notes. So look at your notes. What did we use? So look at your notes, right? So this is the cool thing about class this year is everything is open notes. So with parallel lines, what do we got here? What can we use? And I will just wait until I hear from people. Oh, good. Yeah. I should get more people though. So there's about 26 people in this class. So that means there should be 26 responses. So again, we have parallel lines. What parallel line rule are we going to use, right? Is it going to be corresponding, alternate interior, alternate exterior, or consecutive interior? Okay. All right. And be careful, right? So let me go through this. So some of you guys are like, hey, I'm not sure, or you have a couple of guesses, but you aren't sure if you're correct. So remember, there's only 4, so we can use process of elimination. So corresponding would mean same place, same location. So if we have these parallel lines here, right, the angle has to be touching the parallel line, so it's either going to be C or D, and then it's connected, right? So if D here was on top, then the other angle would be outside the triangle. Okay, so that can't be corresponding. And if C here is on the bottom, then on the bottom here would be outside of the triangle. So we can't use corresponding, right? Everything, all the angles here are on the inside, so it can't be alternate exterior because everything is on the inside of these 2 parallel lines. Okay, and then consecutive would mean they're on the same side of the transversal. But you can see this one's on top, this one's on bottom, so it's not consecutive. So it has to be alternate interior. Okay? Now, a couple of people have been chatting in chat with me about like, well, which one do you pick? And that's the beauty of it, guys. You can pick whatever ones you want, right? We have alternate interior with angle A and angle C, or we have alternate interior with angle D and angle T. It doesn't matter which one we pick, but it changes what property we're going to use. So what do you guys want to do? Do you want to use A and C or T and D? What do you guys want to use? Oh, wow. So I just got 2 votes for T and D. So I'm going to go ahead and use T and D. So I'm going to say angle T is congruent to angle D. And I can just use the shortcut name, right? Because there's only one angle off of those.
And then I can say if parallel lines,
right? So did we have parallel lines? We certainly did. Remember, you can only use this if we have
parallel lines. So if parallel lines, then alternate interior angles are congruent.
Okay. So that's what I said. They're congruent. So what do we have here? Well, I'm looking at one of these. So is the side touching both angles or just one angle? Well, in this case, the side here is touching both angles and the side here is touching both angles. So I'm going to end up using, for this one, I'm going to be using ASA. But if we used A and C, then it would have been angle, angle, side, and the side would have been only touching one angle. Okay, so I'm going to go ahead here and say triangle. I already used these letters, so I'm going to use those letters again. Triangle AET is congruent to triangle CED, and I'm going to say by ASA. So again, if you guys used angles A and C, you would have used AAS. But the whole point here is, once we've proven the triangle is congruent, are all the parts congruent? Yes. And that's the new part, right? So we would say segment AT is congruent to segment CD. And what's my reason? By CPCTC. Okay, and that's the reason there. Okay, and that's the end of our proof. Okay, and I sped things up a little bit by not having to write out all the givens and stuff. So does anybody have questions there? I just got one more thing left where I'm going to show you a real world example, and we'll be good to go from there. Does anybody have any questions? And I appreciate people saying, hey, I don't have questions too, right? But remember, if you have questions and you don't say anything, then I'm not going to be able to help you, right? Remember, speaking up for yourself and advocating for yourself is a skill. It's a trait, right? So make sure you guys are learning to use that, right? Because I'm here to help. And if anybody have questions, I will answer your questions, okay? Thank you guys. I appreciate everyone who's responding. You guys, this is how it should be. I really appreciate you. All right, cool. So why the heck are we learning this, right? Well, so first of all, triangles are the fundamental building block of all shapes. So if you guys can do this with triangles, you can do this with any shape. That's what's powerful. Oh. Okay, so if you can do triangles, then you can do any shape because every shape is made up of triangles. Okay, so that's the power of it. That's why we're focusing so much on triangles. Okay. And then with what we're gonna do next is is there what are the real world applications? Well, construction is definitely one of them because you're dealing with shapes all the time. So if you want the one before it, then I will do that at the end of class. I'll go back to that really quickly. Okay. So another thing is we can use this. Now it's not the best way. We're gonna learn a better way to do this in a couple of months. So I'm just going to preface this. I'm going to show you an example of this, but there is a better way, and we're going to learn how to do that in about a month. Okay? So my example is going to be, okay, here's the Skagit River. Now, unfortunately, there isn't an easy way to measure the width of the Skagit River. It is something that it's too big and it's too dangerous to measure with just like a tape measure, right? You can't be like, all right, here's you, and you're like, you give your buddy the other end of the tape measure and be like, just go across the river, right? That's probably not going to end well, especially when the river is flowing super fast, right? Probably not a good idea, okay? Do not swim in the Skagit River, okay? There's the underwaters can be moving really fast, and if there's a log under the water, oof, not good, right? Not good. So how do we do this? Well, you can use congruent triangles to do this. And I feel like I didn't give myself enough space on that end. So anyways, to show this, what you would do is you would start by drawing a set distance on this side. So let's say, right, you have, this is point A, this is point B, and let's say it's 10 feet. Okay. And the reason why you do 10 feet is then you know the midpoint, right, is 5 feet and 5 feet. Okay. And then what you're going to want to do is you're going to want a target on the other side of the river. So let's say it's a tree. Okay, that's a pretty ugly tree, but there's a tree. Okay, and you're going to want that tree to be perpendicular from your starting point, right? These are all things we can do. So you find a point directly across the river, right? That's perpendicular to the tree. You measure out 10 feet, and then this is where the really cool part is. What you do is you get an eyeglass. And what you do is you come down here, and what you want to do, so you're going to come straight back. And what's really cool here, I know I drew these in red, is what you want to do is you want to make triangles that are congruent. So to make these triangles congruent, what we need to be able to do you see how we have a pair of angles, a pair of sides, right? We just need one more angle. So what you do is you walk backwards so that when your sight line goes like this, that this angle and this angle are also congruent. Okay? And all you have to do is you keep going back from this point until you can see the tree through the midpoint. So if you ever see those surveyors out in the road, right? They have a little tripod down like this, and then they have a little tripod down like this, and then they look, right? They look through that, and then they see the tree over there. Or they can set up another tripod if they want to be more accurate. So when they do that, this just automatically becomes vertical angles. Okay, so what's the big deal here? Well, if this is angle, side, angle, and this is angle, side, angle, these two triangles are congruent, which means this side right here and this side right here are the same. So why is that a big deal? This is the width of the river. So we couldn't measure the width of the river, but we can measure this. Now, the problem with this is you're going to need a lot of space to measure, right? So if there's buildings in the way, that could be problematic, right? So there's a better way of doing this that requires less space that we'll learn in a month. But that's pretty cool. This is called indirect measurement. Okay? So anyways, people are like, why are we learning this? So it's a good way, so you can measure lots of things. So things that you couldn't normally measure. You can also do this with heights. So like the height of a mountain or a building. Okay, it's pretty cool. And it's called indirect measurement. So you're measuring the length of this by measuring something else. Hey, before the end of class, I just want to remind people, you do unfortunately have a homework assignment. I made it really short. It is due by next class, which is the Monday after spring break. Don't wait till the end of spring break to do it. Do it now, okay? Also remember, 80% of your grade is these assignments. So if you guys aren't turning in assignments, your grade isn't looking very good. Use spring break to get caught up with all of your assignments. But most importantly, use spring break to do something that brings you joy and makes you happy. Okay, so with that, if you guys need to stick around and ask questions, I will be here. Take care. Have a great spring break.